Welcome friends, myself Rahul Chimkar and I have teaching experience of 2+ years. I have completed my post-graduation in mechanical engineering. Now moving towards the today's topic, that is gravitation. While talking about the gravitation, it is important to discuss the story of Newton. You know or remember or you may have heard it somewhere else. When Newton was sitting below the apple tree, he experienced a thing that when apple is falling not in any other direction, but always it is falling in towards the earth, that is towards him. Then he started this taking observations and made research on that and concluded the gravitation, force of gravitation. For that, the key points of today's discussion are concept of gravitation, laws of motion, law of gravitation, free fall, acceleration due to gravity, and its calculation. In the next slide, the picture which we have discussed about the story of Newton is shown. Moving to the next slide. Before starting the discussion about the moon revolving around the earth, it is important to know the concept of tangent, what it is. Actually, tangent is a straight line which is touching a circle at single point. Here it is shown in the figure 1. Line AC is a straight line and it is touching at point B to the circle, and that line AC is called tangent. Now let us see the concept. Like a moon, if we will consider a stone tied to a string, and if we will revolve it, shown in the figure 2, we will able to do the discussion about the gravitation. According to the third law of motion, the apple does attract the earth. Like earth attracts the apple, as we have discussed in the story of Newton, apple also attracts the earth. In case of moon, if earth attracts the moon, moon also attracts the earth. This is the third law. There is equal force of attraction. So sorry, not equal force of attraction, but different forces of attraction depending upon their masses. If the mass of particular object, let us say earth, is having higher mass than the moon, then earth will apply higher force of attraction. But according to the second law of motion, for a given force, acceleration is inversely proportional to the mass of an object. What did it say? Let us say force F, for a given force F, then acceleration A is inversely proportional to the mass M. Then how we can write the equation? M is proportional to 1 divided by the acceleration. What it will give us the equation. If we will put proportionality constant as F, we will get F equal to F upon A equal to M. If we will rearrange that equation, it will become F is equal to MA. That is the definition of force we derive from this second law. As the mass of apple or moon is negligible compared to the earth, so earth does not seem to moving towards the apple or moon. As I have told you that even the force is applied by the moon and apple, but the earth do not move towards the moon or towards the apple. We will derive that equation, and you will come to know that why this force is dominant in case of object having higher mass. That is, let us say, capital M. In coming slides, we will discuss it. Let us say capital A is an object having a mass capital M, and small capital B is a mass having is an object having mass small m, and the distance between the centers is small d. Now we will derive the equation. Let us say force is F is the force of attraction between them. Then we can say that force is according to the law of gravitation, force is directly proportional to the product of mass capital M and small m. That means those two bodies which we have considered, and it is inversely proportional to the distance between them. In our case, or in our example, this distance is small d, we have seen in the figure. So by combining these two equations, what we will get equation 3, that is force is proportional to the capital M into small m divided by d square. That is the product of two masses divided by square of the distance between them. By putting proportionality constant capital G, we will get equation 4 from equation 1, 2, and 3. and that will be F equal to G capital M small m divided by d square. Or if we want this equation in terms of F for finding out the proportionality constant G, constant of gravitation, then G will be equal to F d square divided by capital M small m, whereas the value of G is given by the scientist Henry Cavendish, and which is equal to 6.673 into 10 to the power minus 11 Newton meter square kg per kg square. Now let us discuss the importance of this universal law of gravitation. It explains several phenomena which were believed to be unconnected, like force that binds us to the earth, not only us, but any other object which we see, that force which binds that object to the earth. Then secondly, the motion of the moon around the earth. Then the motion of the planets around the sun, and also the tides which you see in case of sea or ocean. That is also the importance of the universal law of gravitation. Now let us discuss the free fall. In simple words, I will say, if there is no other force than gravitational force acting on an object, then the motion is called the free fall. If you will jump from higher altitude, let us say from 5 feet or 10 feet, then you can experience that free fall. Take an object or stone, throw it upwards. It reaches a certain height and then it starts falling down. Because only gravitational force is acting on the object, the velocity will goes on increasing. That means velocity is changing. So we know that there will be an acceleration associated with it because there is change in velocity. Now here the acceleration is due to the gravity, nothing but the G. So force equal to